In this lesson, we're going to look at an alternative from y equals mx plus c to work out the equation of a straight line. Now this is a really useful formula, this one at the bottom, because it allows you to work out the equation of a straight line if you don't know what the y-intercept is. All you'd require is just really one point on the line. So it's more powerful than y equals mx plus c, and that's why we use it from now to maybe higher maths and beyond. Now, if you look at this diagram here, this is just a proof of this formula at the bottom. So if you pick any 2 points, now I've used a bit of algebra here so it looks a wee bit more complex. But say you pick a point P and you call it xy, so it could be 3, 4 or 5, 6, we're just going to call it xy. Now another point A, and instead of calling that xy because we might get mixed up, we're going to call it AB. Now to work out the gradient of this line, what you would do is you would subtract the y coordinates from each other and then divide that by the subtraction of the x coordinates. So how that looks is the gradient of AP is equal to delta y over delta x as before, except this time delta y is y take away b. No, we've not got numbers, but we'll just call it y take away b, and the x coordinates are really x take away a. Okay, so what we can do now to get rid of the fraction is basically multiply up by the value in the bottom. Now the value in the bottom is x minus a. So if we multiply both sides by x minus a, we're left with y take b here. And on this side we've got mx take a. A wee bit of rearranging, just change the sides. Change this over to here and this over to here. And we get y take b equals mx take a. And that's how you create that formula. You'll never be asked to do that, so don't worry too much about that. However, you are asked to use it, so let's look at a few examples here. So these are some easy examples where you know the gradient and you know a point, and you've just to try and work out the equation of the line. Now what I tend to always do is write down my information, so I say that okay, well, the gradient's 3, so m's 3, a is the first coordinate, so the x value 4, and b is the second part of the coordinate, the y value, so minus 2. It's a case of substituting these three values in the correct places. So instead of y take away b, we're going to write y take away negative 2. So that becomes y plus 2. We can write y take away negative 2 if you want. The gradient is 3. And then we're going to have x take away whatever a is. In this case 4. So x take away 4. Okay, to sort all this out, times the bracket out first. So 3 times x and 3 times minus 4. That gives you 3x take away 12. And then to get y on its own, you subtract 2 from both sides. So take away 2 here, you're just going to get y. And take away 2 from negative 12, you get minus 14. Okay, second example here. Find the equation of the line with a gradient of minus 4 and it passes through 0, minus 6. So again, write down your information. So m is negative 4. A is 0 and b is negative 6. So we're going to have y take away negative 6. That becomes y plus 6. The gradient's negative 4. So negative 4 times x take away a, so x take away 0. Right, times out the bracket again. So leave y plus 6. Negative 4 times x is negative 4x. Negative 4 times negative 0 is just 0, so you don't need to put anything there. To get y on its own, take away the 6. And there you have it, y equals negative 4x, take away 6. Now if you're given more than 1 point, which we'll look at in the later examples, then either one will work. Something to bear in mind.